The diverterless supersonic inlets, DSI, leading into serpentine inlets, S-ducts, can obscure the reflective surface of the engine from radar detection. DSI intakes save weight, reduce complexity, and minimize radar signature. Additional low observable features include a flat fuselage bottom holding an internal weapons bay, sawtooth edges on compartment doors, mesh coverings on cooling ports at the base of the vertical tails, embedded antennas, and radar-absorbent coating materials. While the aircraft's fin strakes and axisymmetric rear areas may expose the aircraft to radar, the overall stealth shaping is robust and considerably more capable than the Russian Sukhoi Pak-FA. The J-20 emerged from the late 1990s JXX program. In 2008, the PLA Air Force endorsed the Chengdu Aerospace Corporation's proposal, named Project 718. The aircraft proposed by Shenyang is larger than the J-20. In 2009, a senior PLA Air Force official revealed that the first flight was expected in 2010-11, with entry into service in 2019. On 22 December 2010, the first J-20 prototype underwent high-speed taxiing tests outside the Chengdu Aircraft Design Institute. 3 months later, the first J-20 prototype made its maiden flight in Chengdu. The aircraft is powered by two WS-10G vector thrust turbofan engines, which can each produce 30,000 pounds of thrust. This machine is specially designed and manufactured by Liming Shenyang, China. The WS-10G is equipped with thrust vector-controlled TVC nozzles, devices designed to control direction, to reduce radar cross-section, RCS. The J-20 avionics aim to obtain situational awareness through advanced sensor fusion, while denying situational awareness to the adversary through stealth and electronic warfare. The J-20 features an integrated avionics suite consisting of multi-spectral sensors capable of providing omnidirectional coverage. Official information on the type of radar that J-20s use has not yet been released publicly. Some analysts believed that J-20s use Type 1475 KLJ5 active electronically scanned array ESA radar with 1856 transmit-receive modules, but more recent information revealed that this radar was designed for upgraded versions of the J-11D. Other analysts point out that, based on the nose cross-section of the J-20 and known data about a single transmit-receive module surface in the J-16's ESA radar system, J-20s likely contain 2,200 transmit-receive modules. The main weapon bay is capable of housing both long-range air-to-air missiles, AAM, PL-12, PL-15, PL-21, and precision-guided munitions, PGM LS-650s, LS-6-100s, while the two smaller lateral weapon bays behind the air inlets are intended for short-range AAMS PL-10. The F-22 Raptor is listed as the world's first fifth-generation stealth fighter jet. It is considered the best fighter jet owned by the United States, U.S., after the late 1990s Cold War. This sophisticated fighter made by Lockheed Martin was only produced 187 units, and was exclusive because no other country had it. The The F-22 Raptor is the most expensive fighter at US $120 million per unit, or US $361 million per unit, when added to development costs. The fighter jet was made from 1996 to 2011. Its maiden flight was September 7, 1997. The F-22 was introduced or officially launched on December 15, 2005. The Lockheed Martin F-22 Raptor is an American twin-engine single-seat all-weather tactical fighter aircraft developed and manufactured for the United States Air Force, USAF. As a result of the Advanced Tactical Fighter (ATF) program, the F-22 is designed to assume the primary role of an air superiority fighter, but also have the capability to conduct ground combat, electronic warfare, and intelligence signals. Prime contractor Lockheed Martin is responsible for the majority of the airframe and weapon systems, and performs final assembly, while partner Boeing is responsible for manufacturing the wings, rear fuselage, avionics integration, and pilot training and maintenance systems. The F-22 Raptor has 4 wing hardpoints, each rated to carry 2,270 kilograms, which can carry AIM-120 AMRAAM or external fuel tanks. The Raptor has 3 internal weapons bays. The main weapons bay can carry 6 AIM-120C AMRAAM missiles or 2 AMRAAM. And a variant of the internally mounted M61A2 Vulcan rifle, General Dynamics linkless ammunition, holds 480 rounds of 20mm ammunition and feeds the gun at a rate of 100 rounds per second. The F-22 Raptor is designed to carry air-to-air missiles in internal bays to avoid disrupting its stealth capability. The launch of this missile is preceded by the opening of the armament valve, and then the missile is pushed down by a hydraulic system. This aircraft can also carry bombs, for example the Joint Direct Attack Munition, JDAM, and the newer Small Diameter Bomb, SD. In addition to internal storage, the aircraft can also carry weapons at 4 external points, but using this greatly reduces its stealth, speed and agility capabilities. The Pratt & Whitney F119PW100 F-22 twin-turbofan engine has thrust guidance capability. This pointer can adjust the rotation axis pitch to about 20 degrees. Maximum thrust of the engines is still under wraps. The aircraft's maximum speed is estimated to be around Mach 1.2. when in supercruise without external weapons. With the afterburner, according to Lockheed Martin, the speed is more than Mach 2.0, 2,120 km per hour. The F-22 uses the AN/APG-77 ESA radar designed for air superiority and ground attack operations, which is difficult to detect by enemy aircraft, uses an active aperture, and can track multiple targets simultaneously in any weather. The AN/APG-77 changes its frequency 1,000 times every second, making it also very difficult to track. This radar can also focus emissions on opponent sensors, making enemy aircraft experience interference. Information on the radar is processed by 2 Raytheon processors, each of which can perform 10.5 billion operations per second, and has 300 megabytes of memory. The software on the F-22 consists of 1.7 million lines of code, most of which process data captured by the radar. The radar has a range of about 125 to 150 miles, and is planned to be upgraded with a maximum range of about 250 miles. The construction of the F-22 is 39% titanium, 24% composite, 16% aluminum, and 1% thermoplastic by weight. Titanium is used for its high strength-to-weight ratio in stress-critical areas, including some bulkheads, and also for its heat-resistant qualities in the hot parts of the aircraft. Carbon fiber composites have been used for the fuselage frame, doors, intermediate spars in the wings, and for the skin panels of the honeycomb sandwich construction. The cockpit is equipped with a hands-on throttle and control stick. HOTAS. The cockpit has a 6-color liquid crystal display. Kaiser Electronics' primary projection multifunction display provides an aerial plan view and ground tactical situation. Including threat identity, threat priority, and tracking information. 2 displays provide communication, navigation, identification, and flight information. 3 secondary displays show air and ground threats, store management, and air threat information. The BAE Systems head-up display, HUD, shows target status, weapon envelope, and firing cues. A video camera records data on the HUD for post-mission analysis. The F-22 can also maneuver very well at supersonic and subsonic speeds. The use of thrust control allows it to make sharp turns and perform extreme maneuvers such as the Herbst maneuver, Pugachev's Cobra, and Culbit. The F-22 can also maintain a constant angle of attack greater than 60 degrees. Altitude also affects attack. In a military exercise in Alaska in June 2006, the F-22 pilots said that the ability to fly at a higher altitude than other aircraft was one of the determining factors for the F-22's absolute victory in the exercise. The F-22A offers complete stealth, unlike the F-35, which has an excellent radar profile from the front, a less stealthy profile from the sides, and the most stealthy profile from the rear quarter. Note that stealth is not see-through. This simply shortens the range over which aircraft can be detected by adversaries on the ground or in the air, and makes the engagement's radar lock more difficult to reach and maintain. The F-22's short-range stealth rating is far from all enemy positions, even those using the new VHF radar.